In the last video we discussed the notion of direct simplicial approximation, and in this video we're going to prove some additional properties of that. The first thing we're going to do is about composing approximations. So the idea is we've got three abstract simplicial complexes, K, L and M, and then we've got two continuous maps, P from mod K to mod L and Q from mod L to mod M, and so we can compose them to get QP going from mod K to mod M. And we're going to suppose that F is a direct simplicial approximation for P, so that means that F is a simplicial morphism from the complex K to the complex L. And similarly, G is going to be a direct simplicial approximation for K, so it's going to be a simplicial morphism from L to M. And the claim is that we compose G, if you take G composed with F, so that's a simplicial morphism from K to M, then the claim is that that's a direct simplicial approximation for Q composed with P. And then also we're going to say that the identity map on K is a direct simplicial approximation for the identity map on the geometric realization of K. So the proof of this first thing, okay, so we have to consider some point x in mod K, and we're going to put y as p of x, so that's lying in mod L, and z is q of y, or q composed with px, so that's in mod M. So the direct simplicial approximation property for F says that f of the support of x is contained in the support of y. And we can apply g to both sides, right? So, this is an inclusion between two subsets of vertices of L. And g is a map from the vertices of L to the vertices of M. And so we apply g to this, we get that g of f of sub x is contained in g of sub y. Or in other words, G composed with F of sub x is contained in G of sub y. On the other hand, G is a direct simplicial approximation for Q, and that means precisely that G of the support of y has got to be contained in the support of Z. And so we just combine this conclusion with this one here. We see that G composed with F of the support of x is contained in the support of Z, which is, and Z, remember, was here Q composed with P of x, so we're saying that G composed with F applied to support x is contained in the support of Q composed with Px. And that's precisely what it means to say that G composed with F is a direct simplicial approximation for Q composed with P, which is what we were supposed to prove. And then we recorded this fact about identity maps. That's it's a kind of standard thing in category theory. Whenever we have a thing about composition, we have a kind of a corresponding thing about identity maps, but which we chose to write down, but it's more or less clearly true. So the next thing we want to say is about how direct simplicial approximations interact with homology. So we're going to make this definition here, that if we've got some map P from mod K to mod L, and we're going to assume it's directly approximable. In other words, that there exists a direct simplicial approximation. And so we define P lower star, map from H star K to H star L, just to be the same as F lower star, where F is any choice of direct simplicial approximation for P. Now you might worry about whether that's well defined, because the direct simplicial approximation is not unique. But we did prove this in the last video. If you've got two different choices for F, say F and G, then they're going to be directly contiguous. And we also proved even earlier than that directly contiguous maps have the same effect in homology. So it really doesn't actually matter which direct simplicial approximation we choose. We're going to get the same answer as the map H star K to H star L. So it's legitimate just to call that map P lower star. And as a corollary of that, we have this kind of functoriality property, that if we've got maps P from mod K to mod L and Q from mod L to mod M, and these are both directly approximable, then the claim is that if we take Q composed with P lower star, that's the same as Q star composed with P star. And if we want, we can formulate that in terms of category theory. We have our category first category has to be the category of where the objects are abstract simplicial complexes, and the morphisms are directly approximable maps between the geometric realizations. That gives us a category, and this corollary is essentially saying that homology is a functor from that category to the category of abelian groups. And the proof is straightforward. So we choose direct simplicial approximation f for p, direct simplicial approximation g for q, and so by definition, p lower star is the same as f lower star, and g lower star is the same as q lower star. And by what we've seen already, g composed with f is a direct simplicial approximation for q composed with p. So q composed with p lower star is g composed with f lower star, which is the same as g star composed with f star, so everything fits together as claimed. So that shows us that homology behaves very well for directly approximable maps. Of course, not every map is directly approximable. We'll have to deal with that later. We have a theory of indirect approximations, but that will do for the minute. We also want to introduce a slight variation on the definition of a direct simplicial approximation, just a slightly different way of phrasing the same definition. So we're going to do that in terms of open stars. Okay, so we've got some vertex A of k, then O star AK is going to be the set of points x where the coefficient of A is strictly positive. And so that's easily seen to be an open subset of the realization of k. So here's the lemma. So we've got some continuous map P from mod k to mod L, as we've been discussing, and a map F from vert k to vert L. And we're going to say that F is a direct simplicial approximation for P if and only if P sends the open star of A to a subset of the open star of FA. That's for every vertex. Okay, so to prove this, well, we have to consider this condition x. When is x in the open star of A? Well, by definition, that's just equivalent to the condition that xa is strictly positive. But also, xa is strictly positive. That's just the same as saying that A lies in the support of x. So x in the open star of A is the same as A in the support of x. And in exactly the same way, we can apply the same logic to point Px and the vertex Fa. So Px lies in the open star of Fa. That's by definition the same as saying that the coefficient Px Fa is strictly positive, and that's the same as saying that Fa is in the support of Px. So what's the original definition of what it means for f to be a direct simplicial approximation? That means that for every x, f of the support of x is contained in the support of Px. And so what does that mean? Okay, this means that whenever A is in the support of x, whenever x is in mod k and then A is in the support of x, then Fa has to be in the support of Px. That's what it means to say that f of the support of x is contained in the support of Px. Okay. But now we know that A in the support of x is equivalent to x being in the open star of A, and Fa in the support of Px is the same as Px being in the open star of Fa. So we can rewrite this condition like this. For all x and A, if x is in the open star of A, then Px is in the open star of Fa. And then we can just change the notation there a little bit. It says for all A, P of the open star of A is contained in the open star of Fa. And that's what we were supposed to be proving, that f is a direct simplicial approximation if and only if P sends the open star of A into the open star of Fa for all A.